Today, we talk about how I hit 95 on I-95.
And I do a burnout.
Based on Robert F. Blitzer's #1 selling book, Calculus 5e, comes one of the greatest examples of all time.
Alright, so let me tell you a story. About a week ago, I went to Miami with my friend Sebastian. We hit the highway at 95 miles per hour. I mean, by now it's no big deal. We get pulled over around 6 times on the way there, but I mean, it's completely worth it. Now, we can see angular speed through this. Let me tell you the formula. For angular speed, the formula is this W, which is called omega. Not that bar soap, but omega, the letter, over theta over T. Now, let me tell you this. This is not your drinking tea, this is T as in time. Once we have this formula, we can talk about our revolutions per minute. Now, when we're driving down there, we're going 3,600 revolutions per minute. We can find this in radians by setting up a proportion. Now we know that 2 pi radians are in 1 rotation. So we set up a proportion, and we multiply, and we see that we have 7,200 radians per 1 minute. This can obviously be converted to seconds, milliseconds, tenths of seconds, bajillions of seconds.
Now, as my friend Andres just told me, angular speed and linear speed are different, but first you need to find angular speed to find linear speed. Now, to help illustrate this point, I have a lens. Alright, whatever. I don't need that other part anyway. Let's say, how about a clock? Now, if we have a line going from a center point on that clock to the outside, and we add time to the equation because it's a clock, that line is in motion over time. Say the speed of the inside point of that radius and the outside point of that radius is the same because it's turning at the same speed. So, if I have a point on the inside of the radius and on the outside of the radius, over time, they're moving the same speed. That's angular speed. However, the linear speed is different. What do I mean by that? Well, the inside and the outside, because it is a circle, will be traveling different lengths, different distances. We're working backwards this time. So say we have a bowling ball with a linear speed of 75 meters per second. Why is this going so fast, you might ask? Because it was bowled by none other than John Cena! This bowling ball also has a radius of 15 meters. Because only something that big could fit such a big man. So to do this, we have 75 meters a second times 1 over 15 meters. Now, we convert those to revolutions a second, which would bring us to 5 radians a second times 1 revolution over 2 pi radians. So, we'll do a decimal approximation here because we can. If you multiply those together, that brings us to 7.85 revolutions a second, which is our angular speed. And now, a burnout. So, say we are given omega, the Greek letter, not the Greek yogurt. Omega equals 4 revolutions per second. We use the formula V equals R times omega to find the linear speed. Before applying the formula, we must express omega in radians per second. We have 4 revolutions of the tire in 1 second, which is incredibly slow because this is not real life. Now, we multiply that times 2 pi radians over 1 rotation because 2 pi radians is the circumference of the circle. Now, when we simplify that, that equals 8 pi radians over 1 second. Whether those are key lime or pumpkin or whatever your heart desires, it's 8 pi over 1 second. 8 pi is the speed of the tire rotating in 1 second. So now that we've found the angular speed, which is 8 pi over 1 second, we can now find the linear speed. The radius of our tire is 10 feet. We've established that our radius is 10 feet. We multiply that times the angular speed, which is 8 pi over 1 second, which gives us our linear speed, 80 pi over 1 second. Ladies and gentlemen, burnouts are expensive. If you would like to help us keep this joyous activity alive, please contact us at 1-800-BURNOUTS. Every cent counts. Every cent counts. Stop the cameras.
Now imagine a fire mixtape. By this mixtape, I mean the CD. So we have a circular object, right? Imagine this mixtape is so big, it's so popular, it's 10 feet. Has a radius of 10 feet. Now, this mixtape rolls and gets 6 revolutions per 1 second. Check this out, we're gonna convert this to see how many inches per minute it moves. So, we have 10 feet over 1 times 12 pi radius over seconds. Why do we have this 12? Well, because we have 6 revolutions. Remember, 1 revolution is 2 pi. So therefore, since we have 6 revolutions, we have 12 pi radius. So once we have this, we're gonna cross multiply, and we have to put a proportion of 60 seconds over 1 minute. Once we get this, we get 2. That's a big number. 271,444 inches per minute. Ladies and gentlemen, today we've seen a lot. You know, we've seen burnouts, we've seen speeding on I-95, we've seen, you know, songs, but all of this in the name all of this in the name of good old math.
Wrap it up here, wrap it up.
Now remember, if there's anything to remember, 1, if you'd like to donate to our Burnout Foundation, please call us. 2, if you'd like to speed with us, please call us. And 3, because math. This has been a project for math. Good night, everyone.